In the past, when people said a car was turbocharged, they immediately thought the car was fast and had more power. But how could a device increase an engine's power? So today I'm going to show you what a turbocharger is and how it works. Hey engineering moms! Today we're going to dive into a component that's synonymous with performance and efficiency for many vehicles, the turbocharger. Have you ever wondered how that smaller car manages to have such impressive response and power? Or how some engines can deliver a lot of power without being huge? The answer is often under the hood, working silently or not so silently to transform exhaust gases. To start, let's get straight to the point. What is a turbo? At its core, a turbo or turbocharger is a mechanical device with a very clear mission: to force more air into the engine. Think of your car's engine as an athlete. The more oxygen it can breathe in, the more energy it can generate, right? It's the same thing with an engine. More air means more oxygen available to burn more fuel, and more fuel burned translates into more power. But how does the turbo manage this feat of pushing more air into the cylinders, going beyond what the engine can draw in on its own? The great trick of the turbo is that it takes advantage of something that would otherwise be completely wasted: the exhaust gases. Yes, those hot and pressurized gases that come out of the engine após a combustão, which would normally be thrown away through the exhaust. The turbo captures these gases and puts them to work. Imagine you have a garden hose, and instead of letting the water flow freely, you direct it to spin a small water wheel. It's a simple analogy, but it illustrates the principle well. The exhaust gases, with their kinetic and thermal energy, are directed to a part of the turbo called the turbine. The turbine is like a small propeller or a pinwheel designed to spin at very high speeds when hit by the exhaust gases. And when I say very high speeds, we're talking about hundreds of thousands of revolutions per minute. That's really impressive. But what's the connection between this spinning turbine and the extra air the engine needs? Well, this is where the genius of the design comes in. The turbine is connected by a shaft to another component we call the compressor. Think of this shaft as a bridge that connects the two parts of the turbo. And that's why we call it a turbocharger. So, when the exhaust gases make the turbine spin, the shaft spins along with it, and consequently, the compressor also starts spinning. The compressor, in turn, is a kind of fan or air pump, but much more powerful. It's positioned at the engine's air intake. Even before the air reaches the cylinders, what it does is suck in the ambient air and compress it. It's like using a bicycle tire pump, but on a much larger and much faster scale. The air, which was previously at normal atmospheric pressure, is now compressed and forced into the engine. But why is compressing the air so important? Do you remember our analogy about the athlete who needs more oxygen? When the compressor forces air into the engine, it is actually packing more oxygen molecules into a smaller volume. It's as if instead of the engine drawing in a normal amount of air, it receives oxygen-rich air. With more oxygen available in each combustion cycle, the engine can burn fuel more completely and efficiently. And the result? It's an increase in power and engine torque. The need to increase its physical size, that is, its displacement. And here's a crucial detail for efficiency: the intercooler. Have you ever noticed that when you compress something, it tends to heat up? Think about a tire pump. When you're using the pump, its body heats up. The same thing happens with air when it's compressed by the compressor. Hot air is less dense, meaning it contains fewer oxygen molecules per volume. To maximize the amount of oxygen that reaches the engine, we need this compressed air to be as cool as possible. And that's where the intercooler comes into play. It's basically a radiator for air that cools the hot pressurized air coming out of the compressor before it reaches the engine. By cooling the air, the intercooler increases its density, ensuring that the engine receives as much oxygen as possible for an even more, mais potente e eficiente. Então, to sum up the cycle, the exhaust gases, which would otherwise be wasted, drive the turbine. The turbine then, connected by a shaft, makes the compressor spin. The compressor draws in and compresses the ambient air. This compressed and hot air passes through the intercooler to be cooled. And finally, the cold and dense air is sent to the engine cylinders, where it mixes with the fuel for a stronger explosion, generating more oxygen. It's a continuous and ingenious cycle of energy recovery. But what about that hiss we hear? Is that the sound of the turbo? Actually, no. That hiss we hear is what we call a blow-off valve. Imagine you're in a cycle of compressing air and sending it to the engine. But when you take your foot off the accelerator or shift gears, the engine's air intake is closed, but the compressor is still compressing air. But now it has nowhere to go. So that this pressure doesn't increase exponentially, this valve works by opening to release the compressed air. The noise or hiss we hear is basically the sound of the air being quickly released by the valve. But there's a difference here. The priority valve operates on the air intake. However, we have another valve for controlling the exhaust gases, which we call the wastegate. Basically, it controls the pressure of the exhaust gases, acting as a bypass when there is excess pressure in the turbine. With this, it controls the speed of the turbine and consequently the pressure generated by the compressor, preventing both the turbine and the engine itself from braking. Now you might be wondering, is there any other way to force air into the engine? Yes. There is, and it's called a supercharger or a mechanical compressor. The main difference between a turbo and a supercharger lies in how they are powered. While the turbo uses the energy from the exhaust gases, the supercharger is driven directly by the engine, usually by a belt connected to the crankshaft. This means that the supercharger takes a bit of power from the engine itself to operate, while the turbo makes use of energy that would otherwise be wasted. That's why the turbo is often praised for its energy efficiency, as it turns waste into performance gains. And speaking of efficiency, it's important to debunk a common misconception. Many people associate a turbo only with sports cars and high-performance vehicles that consume a lot of fuel. However, under normal driving conditions, modern turbocharged engines can, surprisingly, be more fuel efficient than their naturally aspirated counterparts. This happens because the turbo allows manufacturers to use smaller engines with less displacement to generate the same power as a larger naturally aspirated engine. A smaller engine, when it's not under high power demand, consumes less fuel. The turbo kicks in when you need that extra power, but in everyday driving it can help save fuel. In fact, many automakers, in order to increase power without increasing pollutant emissions, are choosing to design their cars with turbochargers. It's a technology that has really democratized access to performance levels that were previously limited to large engines. The engineering behind the turbo is a brilliant example of how we can optimize resources and turn what would be a byproduct into a valuable source of energy. So, the next time you hear a whistle, characteristic of a turbo, or feel that extra push in a car, you'll know it's not magic, but smart engineering working to harness every bit of energy. If you've made it this far and enjoyed the video, make sure to subscribe if you haven't already, give the video a like, and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be recognized in our videos. And if you've made it this far, I invite you to take a look at the courses we recommend. So, point your phone at the QR code here on the side or click the link in the description about our courses. There you'll find Excel courses, 3D modeling AutoCAD, public speaking, and many others. These are courses selected by us here on the channel, and we can vouch for their quality, so if you want to boost your career, it's worth checking them out. And if you want to build your online presence and begin producing and recording videos for social media via this QR code here, we've selected the equipment we use here in our studios. And you, have you ever seen a turbo working before? Did you know it improves engine performance? Do you have a car with a turbo? Let me know in the comments. Here on the side, there are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering enthusiasts. Take care, and I'll see you in the next video.